Trần Hoàng Anh 2021-2355. And learn um, build a modeling. Okay. So far, we have seen the most important data handling steps and how to combine them with the flexible processes. Now we will focus on how to build predictable models, use them to score new data points, and validate how well the models will work for the new situation. So, at next, I will do my example. I go to the sample, local repository data. Oh no, sample data and find Titanic training data this decision decision uh, then I go to the decision tree decision tree này. Naive naive bias rule induction example trial here here and here and inspect a different model. So at here, look into the chart of the simple distribution model, which is the output of native E. Select different attribute and expect the chart. Why do some of them show bar and so some of them show line? Which into chart simple distribution model, which is output of naive. Why do some of them show bars and some of them show line? I don't really know. The previous tutorial demonstrate how predictive modeling can reveal insight about your data. You might not have been able to see the effect of gender or family size on survival by just looking at the data alone. This tutorial will now show how can we use this insight to predict future outcomes. So I still draft the Titanic retrieve training still with the native navy Bayes navy and connect it. And after that, after the apply model, the model and add a retrieve from the sample data unsplit. Take this, now this and this. Laboratory to the rest, and then I press the run. To inspect the result is the original unlabeled data with a column for predict classes, yes or no of survive, and two additional column for the confidence of two different classes, yes or no of survival. For example, the first row of the data is predict yes with the 98.7% of confidence and no for 1.3% confident. Yes, we can see that it is here and yes and confident, no. And the prediction of survival and sort data set so that it shows the case with the highest probability of survival. What percentage of the top 10 people with the highest probability to survive is the female? Oh my God, it's really a challenge. Titanic training split data, split data, make split data in its parameter, look at passion and click the edit and click on strategy twice, size 0.7 and 0.7 and 0.3. Okay. So after that, I have naive Bayes and apply model. This will add operator performance into the process performance, connect it lacks. Từ từ. Apply model mà đúng không? Performance. Cái data mà đúng mà. Add naive Bayes to process and connect to the first output of split data. Add output to process. Connect the green model. Connect the green model port from naive with the model input. Connect the second input of split data as a ounce. After that, add operate performance to the process. Connect it labs input port. Here. Oh, nó bé tí. performance add here. Oh, and then here connect both port performance with the result port on the right. Rồi, xong press the run. Split the label into two parts. One is training and one is the testing performance, and use performance operator to calculate how well the model does work on the challenges. Cross-validation. In the last tutorial, we saw how easy it was to create an estimation for the accuracy of the model by splitting your data into a training and testing set. What if that the training and test set had significant difference between them? Our performance estimate might be based on particularly easy or hard tests. This tutorial introduced a technique called cross-validation to make sure each data point is used as often for training as is for testing, which avoid this problem. The training and add operator cross validations. Here's connect it. Start in the bottom. Now the small icon, in the corner, we call it an icon of yes. Here is subsets. Training and testing. Go back to the A and connect the green model. Connect the green model. Oh, and is here. Double click the process and it has two subset training and testing at decision tree. Decision tree. Here. This. Connect it work delivering training and apply. Port delivering training data on the left and output. Okay. Then the testing. Apply model. Operator performance to testing. Make the lab. Connect the model and testing data from lab and also add operator performance to the testing. Connect the output of apply model with performance. Huh? Connect the output apply model with performance and the output of performance with a per. Yes, no. No. Here. Uh, okay. Just what unfollow. Next, I will go back to the process and connect the green one model and average port to the rest. Connect the green model and yellow average performance to the result and the yellow. Okay. Press the run. and we will have occurrences about this step only works if you had an internet connection and have registers. Okay. So we don't have it. So we now with tutorials about the visual model comparison. Uh, ROC curve or receiver operating characteristic are well known to visualize the performance of the model. The curve of the better models move to the top left, and perfect model produce a line that goes straight up and then trace to the right. Titanic training and compare ROC to the output. Double click the compare rocks. The process will happen. Add three operators is decision tree. Naive Bayes and rules inductions. Connect the input of learn which one learning data. Here's connect the output of the learning operator with the model part in the right. Okay. Mod. Then after that, I will go back to the process and connect the ROC to the result and press the run. And we can see that there were the line and the curve that have the higher value is the decision tree. So we probably choose a decision tree between three attribute. I finished some of the more important techniques, and sourcing is very easy where the same operating model. Okay, that is finished. Stop share.